Welcome back. We are still in 1.5 and we're now going to be looking at piecewise defined functions. So again, these ones look differently on different parts of their domain. So for example 4, we are looking at graphing our piecewise functions. So we want to determine the domain and the range and whether y is a function of x. So remember, once we have the graph, we can use our new tool of the vertical line test to check that. So in this case, we have f of x defined as equal to just 2 when x is less than -1. And then it's going to be equal to -2 when x is greater than or equal to -1. So we're going to be really careful about where those two functions meet up. Sometimes they might meet, sometimes they might not. So we got to make sure that we clearly indicate what's going on at those transition spots. All right, so let's work our way left to right. Now the first part of our domain is when x is less than -1. So -1 is going to be just on the left side of our vertical axis, and we want it to be equal to 2 when it's less than -1. So, if we went to -2, we would go up to 2. -3 would be 2. -4 would be 2. And we can kind of see what's going on here. Now, the million-dollar question is, what happens at -1? When x is -1, where do we go? Do we go up to 2? And the answer is no, because look at the second part of the domain. When x is greater than or equal to -1, it behaves like -2. So we don't want to put a point up here at 2 when we're at x is equal to -1. Instead, we want to get as close as possible, so we're going to put an open dot there, and then we'll fill it in the rest of the way. So we don't really need to know about those dots in there. We'll just make it a big solid line. So we have this solid line pointing to the left for the first part of that function. Now the second part, it looks like -2, and it starts right at x equal to -1. So now we will put a solid dot here. And then we're going to want to work our way to the right with a solid line. So again, open dot here because it's a strict inequality, but a solid dot here because it's greater than or equal to. Now again, it's a little hard to see, but that is an open dot up there. So, and we can obviously, they don't meet. Now, if we wanted to do the domain and range, so remember, domain, we can use our vertical line and work our way left to right, or however you want to do it. So we can see that we're always hitting it, always hitting it. Even at x equals -1, even though there's a jump, it's still hitting the graph down here, and then it continues to hit it. So the domain should be all real numbers. So -infinity to infinity. And then the range is a little trickier. Remember, we want to use that horizontal line and pass through it. So we're not hitting anything, not hitting anything, and then wham, we're hitting -2. Not hitting anything, not hitting anything, not hitting anything, and then wham, we're hitting +2. And then not hitting anything, not hitting anything, and not hitting anything. So there's only 2 numbers in the range. Now, because it's 2 individual numbers, we shouldn't use square brackets. We shouldn't use parentheses. What we should use is curly braces, because there's only 2 numbers in that list. There's not an infinite number. So curly braces are the way to go. All right. And then the final question, is this a function? Well, we already kind of passed our vertical line through it to find the domain, and it only hits it in one spot, so yes. Y is a function of x. Now, even though they didn't use y here, well, it's okay. All right, we know what they mean. Let's do this one. This one's a little more complicated. So we got the 4 minus x squared behaves that way on this part of the domain from -2 to 2, including -2 and 2. And then it behaves like x minus 2 when x is strictly greater than 2. Well, so let's, again, work from left to right. So what about over in here? You know, all over in here beyond -2. There's nothing, right? There's nothing there. The only time we start drawing points is once we get to x equal to -2. So what happens at x equals -2? Well, if we plug it in, -2 squared is positive 4. 4 minus 4 is 0. So we're going to want to put a solid or an open dot here. You better be saying solid because of that less than or equal to here. So a solid dot would go right there. And let's do it easy. Let's go with -1. What happens with -1? -1 squared is positive 1. 4 minus 1 better be 3. And it's another solid. 0. Well, you can see that's going to be 4. Positive 1 squared is 1. 4 minus 1 is 3. And then positive 2. 2 squared is 4. 4 minus 4 is 0. Solid or open dot? Yeah, solid. Solid dot because of that less than or equal to. So we can kind of see our parabolas in there. And it doesn't go on forever. It's limited. Now we just got to do the x minus 2. So when x is strictly greater than 2, so let's not start at 2, let's start at 3. Anything greater than 2, and just kind of get the pattern, and then we'll try to transition them together if we can. So when x is equal to 3, 3 minus 2 is 1. So that puts a point here. 4, x equal to 4. 4 minus 2 is 2, so that's going to put a point right here. And we can kind of see the pattern going on. So now the question is, since we know it goes something like that, what happens in between? Do we connect it? Well, the easiest way to tell is to plug in 2. Now plug in 2 into that second one. If we plugged in 2, 2 minus 2 is 0. And that's the same thing we got up here. So because those two y values match in both branches of that piecewise function, then we can just connect the dots. So this is all one continuous curve and line, and that's it. There's no arrow on this side, no arrow or nothing. It just kind of bounces and goes off like that. So that's our graph. All right, let's do our domain and range. So what would our domain be? So remember, use that vertical line. Nothing, 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 wham. It's x equal to -2, and it keeps hitting, hits the whole way after that. And because it's a solid dot, we want to include -2 in the domain. And it goes all the way to infinity. The range, well, horizontal. Nothing, 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 wham. Starts hitting at 0. Keeps hitting, keeps hitting, keeps hitting. Stops hitting on this one, on the curve, but it keeps hitting on this line. So it's hitting it forever. So we want to start at 0 and include it and go all the way to infinity. And now the final question, is it a function? Vertical line test, 1 point, 1 point, 1 point, 1 point, 1 point. So y is a function of x. Boom. All right. So a lot to that one because of the 2 branches, and sometimes they might have 3 branches, so be really careful on those ones. So we'll stop here, and then we're going to start looking at increasing and decreasing functions. Ooh, fun. See you soon.